Hey everybody, this is Mrs. Lee, and I'm so excited to do a quick math lesson with you. I'm going to be talking about your SOL 3.1a, which has to do a lot with place value for third grade. Now, you can see that I'm using the document camera and I have some place value blocks. I'm also going to be writing some as well as telling you some different things. So I'm looking forward to let's getting started. So here goes. What you see in front of you right now is a review of place value that you are getting started learning in third grade. Can you think about what place values you might be seeing right now? Which ones are represented? If you recognize I have a comma right here, you know that these three go together, and then this starts a new set of place values. This is called the hundreds period, and then what comes on this side as we keep going is called the thousands period. So you should hear some clues right there of words I'm getting ready to use to label our place values. This one right here, the smallest one, what do you think it is? You're right, this place value represents the ones. The next place value in the hundreds period, what is it? You got it, it's the tens. The one right here, as we continue to increase our place values, you got it, it's the hundreds. And finally, the last one we're going to be working with for today, and it's the largest one. This is the thousands. Way to go. Let me let you look at these and get these words in your heads. Ones, tens, hundreds, thousands. Okay, moving on, we talk about in third grade, as we learn our place values, two different ways to write our numbers. We talk about standard form, which is just taking a number and writing it out. And we also talk about expanded form. An expanded form is giving each digit its value. As we go through this video together, this is just a quick side note. Please make sure you're listening for these math vocabulary words because they're going to be really important as we continue to learn. So standard form of a number is just writing it the regular way. Expanded form is giving each digit its value. So this number, say it with me, 541, in standard form looks like this. But in expanded form, it looks like this. The value of the 5 is 500 plus the value of the 4, which is 4 tens. The value of the 4 is 40. And then the value of the 1 is just 1. So 541 is the same as 500 plus 40 plus 1. Okay, let's try another one. This number is a little bit bigger. As you can see, it goes up to the thousands place, all right? So let's try it. First, let's say it together. 4,376. Let me say it one more time. 4,376. This is written in standard form. But now we're going to break it down and we're going to write it in expanded form. And when we do that, let me remind you, we give each digit its own value. So the value of this 4, which is 4 thousands, is 4,000. Plus the value of this 3, this is 3 in the hundreds place. So the value of the 3 is 300. I've got 7 tens, and the value of 7 tens is 70. Good. And then I have 6 ones, and the value of the 6 ones is 6. So standard form to expanded form, the number keeps its same value, this is just a breakdown letting you know what each digit is worth. All right? Now, I want to step away and show you something I made. Can you see these two squares I made? I found some really cool paper that has waves on it, and I folded squares. All right? But I want to show you something. I folded my squares two different ways. I ended up with the exact same shape, but I made them two different ways. This one right here, I made it by taking my whole piece of paper and I folded it in half, and then I folded it in half again, and I got a square. The second one, I made this square by taking my big sheet of paper, folding it in half diagonally into a triangle, and then folding the sides in. But look, I also made a square. And the reason that I'm showing you that is because I want you to see that there are many different ways to make the same thing. And that works with numbers as well. There are different ways to make the same number. That's called being really flexible in your thinking, if you can think of different ways to make the same number. So this is my main point of my video for you today, the main point of my lesson. We are going to talk about ways to compose, which means build numbers, or decompose, which means to break numbers down and break them apart. Again, just like my squares, I can have the same result, but make them different ways. And we're going to work on that with numbers, okay? One of the reasons that it's really important to be able to compose and decompose numbers is you can figure out what a number is really made of, all right? So let's try it. I want you to notice the number that I'm putting before you right now. The number is 72. Now, you might be thinking, 72. We've already talked about expanded form, so I know that there's 7 tens and 2 ones. So let's make 72 that way. 4, 5, 6, 7, and 2 ones. Let's count this out. 10, 20, 30, 40, 50, 60, 70, 71, 72. But is there another way to make 72? Can we look at 72 and break it down, decompose it, make it a different way? Let's try. What about if I take 110 away? If I take 110 away, I'm going to bring in 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's count these now and see if I have 72. 10, 20, 30, 40, 50, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72. I do. I have the exact same thing, just made a different way. So let me go back 1 second. I want to write the first way that we made 72. You see a sneak peek of my next number. We had 7 tens and 2 ones. Can anybody remember the second way we made 72? To really look at what 72 is made of, here it is again by this image. We had 6 tens, and 12 ones. That was another way that we made 72. Can we think of one more way? See if you can and practice it at home. The number is 72. Let's look at our next number that we have here together. The next number that we're going to be working with is, I'm going to fold my paper over so we can see it, is 148. Now, if I think of 148 and I think of the value of the 1, the 4, and the 8, I could think of 148 like this, with this board that represents 100, 4 tens that represent my 40, and now I'm going to bring in 8 ones. 100, 110, 20, 30, 40, 141, 142, 143, 144, 145, 146, 147, 148. So I've represented 148. But what if I want to make it a different way? What if I would like to break down my numbers and represent 148 a different way? What if I took away a 10? Well, I can't just take it away and not replace it with anything. I would need to replace the 10 that I just took away with 10 ones. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's count our number again. 100, 110, 120, 130, 131, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. That's another way to write 148. Just like last time, let's take a moment to write these down. So the first way that I represented 148 was 100, 4 tens, and 8 ones. Then remember we took a 10 away. We still had our 100. Then we had 3 tens. And then we had, anybody remember? This whole collection right here, 18 ones. Let's look at it this way. Let's try one more time with this number. Here is my 100, 3 tens, and 18 ones. That is 148. But what if I want to break down this? This is 100, and it is composed of 10 tens. So now let's replace this with 10 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, let's see what we have here. Let's count it together and see if we still have 148 a different way. 10, there we go. Now you can see my hand. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 110, 120, 130, 131, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 148. Now, how did we just represent 148 a different way? Did we even have any hundreds in this? No, we didn't. How many tens did we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This time, to make 148, we had 13 tens. And how many ones? You got it, 18 ones. And that still makes 148. All right, we're going to move on to a bigger number in the thousands place. You ready? Here we go. While I'm putting this down and moving some things from underneath, excuse me, from underneath, see if you can say that number to yourself. I think you've got it. This number is 2,345. Let me say it again, 2,345. I'm going to show you what that looks like with place value blocks. I'm going to use one of these big blocks now. This big block represents 1,000. The reason that this is 1,000 is because it is 10 hundreds, okay? 100, 200, 300, 400, 500, 600, 700, 800, 900, 10 hundreds, or which is the same as 1,000. So that's 1,000. I have another one, making a stack. 2,000, check that out. How many hundreds do we need? You got it, we need 3. 100, 200, 300. How many tens do we need? 4 in the tens place, so that lets me know I need 4 tens. 10, 20, 30, 40. And then how many ones do we need? You're right on track. We need 5. 1, 2, 3, 4, 5. So now let's count this number looking at the place value blocks. 1,000, 2,000, 100, 200, 300. So 2,000, 100, 200, 300, 310, 320, 330, 340, 2,341, 2,342, 2,343, 2,344, and 2,345. So we have represented that. Do you think there's a different way? Oh man, let's see what we can do. What if I took a 10 away? If I take a 10 away, I have to replace it with 10 ones. So now I have 2,000s, 300s, 3 tens, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 ones. That still represents 2,345, just in a different way. So let me go back and write like I did before. The first way that this number was represented was 2,000s, 300s, 4 tens, and 5 ones. Then we broke it down a little bit. We still had our 2,000s, our 300s, then we were 3 tens and 15 ones. What about, let me fill in the word tens there. Good. What about one more way? What would you do if I had my 2,000s, I have my 3 tens, my 15 ones, and my 300s? What if I took 100 away? I would have to replace it with something. Well, 100 is the same as 10 tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I'm going to take this away and replace it with 10 tens. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, I'm going to put them down here and add them to the 10s I already have. And we've got some major counting to do, so hang in there with me. 1,000, 2,000, 2,100, 2,200, 2,210, 20, 30, 40, 50, 60, 70, 80, 90, 100. So this right here makes 2,300, 310, 20, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. Sorry, my hand was in the way, but we just made 2,345 a different way. Let's write how we just made it. Believe it or not, we did 2,000s, 200s. Anybody remember how many tens? 13 tens and 15 ones. That still makes this same number. So we have broken it down and made it a different way. You will be learning more about this with your teacher, but this is just the start of the lesson that is to come. So, a couple things before I conclude. When I have been using the blocks to do this today, this is called a concrete model. A concrete model is what you can put your hands on to make something. But you can also do what we were just doing with decomposing numbers and breaking them down with a pictorial model. What word do you hear when I say pictorial? Do you hear the word picture? Well, let's try that. All right, here comes another number. This number is 174. If I was going to make a pictorial model of 174, I would use a square to represent my 100. I would use a line to represent my tens and a dot to represent my ones. So 174 would look like this. I already have my 100. 10, 20, 30, 40, 50, 60, 70. That represents my 7 tens. And then I'm going to go 1, 2, 3, 4. That represents my 4 ones, 174. Well, if I wanted to show 174 a different way using a picture, I might take away, I'm going to break down some of my tens and see if I still get it. This time, I'm only going to use 100. I'm going to use 4 tens, 10, 20, 30, 40. So now I need to make the rest of my number with ones. Let's see what happens. How many do you think I'll need? If each one of these represents 10, and I'm only using 4 instead of 7, let's see what we get. So I have 100, 10, 20, 30, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74. My goodness, So let's go back up really quickly and look how we started up here. I have 100. I have 7 tens. And I have 4 ones. Well, I have made the exact same number, but I've broken it down and made it a different way. Let's look at this model. I have 100, 4 tens, and let's see how many ones I have to make my number 74. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, and 34 ones. 100, 7 tens, and 4 ones makes 174. 100, 4 tens, and 34 ones also makes 174. So I hope that you have learned that there are lots of ways that even with our larger place values up to 9,999, those are the numbers that we're working with, that we can make numbers and then make them another way. Before I sign off, I want to review some of the vocabulary that we talked about today in this lesson that you may have heard me say. Some of that vocabulary is place. Some of that vocabulary is value. You heard me say the word digit. I used the word standard form and expanded form. I used the place values that I worked with today were ones, tens, hundreds, and thousands. You heard me say picture model. You heard me say concrete model. You might have heard me say compose numbers and decompose numbers to build them and then break them apart. So as I sign off with this lesson for today, I'm going to give you 3 numbers. I want to see if you can find a way using a pictorial model. Remember that you hear the word picture. If you can find more than one way to show me 82 with your tens and ones, if you can show another way to make 2 ways to make 357 with your hundreds, tens, and ones, and this last one, if you can show more than one way to make 4,039 using your ones, tens, hundreds, and thousands. All right, 3rd grade, I look forward to your next lesson. Keep up the good work. See you soon.